Hello once again. Now we're going to talk about panel analysis, which is basically using data for different entities at different periods. So it could be seen as kind of a combination of time series, although we tend to use not very long series when doing this kind of analysis to make it viable to get to a certain conclusion. So what is panel data? We talked about this in the first class. It's the data that combines cross-sectional and time series dimensions. It involves the same entities, could be individuals, firms, countries, over multiple times or periods. And why is panel data better than the other methods? First is that you can control for unobserved heterogeneity. So if there are time invariant characteristics of individual entities, you can get that depending on the methodology that you use, and you can get more information from the data because if you have time series, you just have one series, right? If you have cross section, you have different entities, but just one period. If you have different entities at different times, you can get more conclusions. You can reach better results about how a certain variable influences the dependent variable because you do this at different entities at the same time. It also helps capturing the dynamic effects. So it's better suited to study dynamic relationships of the timing of events. It allows for analysis of lagged effects and adjustment processes over time, which is also important. And lastly, it helps to identify effects that are not observable in cross-sectional data. For example, impact of a policy change on the same individuals before and after the change. That's something that you can get with panel data. And naturally, everything that has good sides also has downsides. And panel data is it's harder to apply the methodology. You need better information. You have to put more inputs. You have to treat data in a specific way to be able to make the analysis, and that's what I put here. Collect data is more complex because you need more observations, more individuals for a longer period. Sometimes I don't have the data for this, which makes it unviable to use this methodology. The models are more complex. You have to check for serial correlation, which is something that if you don't check, your model can be invalid. And lastly, there's cross-sectional dependence, which means that entities might be correlated with each other, which can lead to biased standard errors if not accounted for. All those things are quite technical, and I'm trying to give you here the tools for you to start analyzing your data. If you really dig into the methodologies of time series analysis or econometrics in general, that can take a whole lifetime. There are hundreds, maybe thousands of economists just developing new methods to try to improve the quality of the methods, the tests, and everything. My plan here is to cover the basics. So you can write your article, write your paper, and present it in a Congress or publicly so you can get ideas to keep developing your methodology. These tools that I'm showing you are a very good step, but still, for you to apply those methods precisely, especially if you're dealing with econometrics or economics data, you will need more than that. This starting point is a very good starting point, but you have to go deeper into these methodologies if you want to write a paper for like a very good journal. And now going specifically to the methodologies, I'm going to talk about three the starting point, the most basic methodologies for panel analysis, which is the pooled ordinary least squares, the OLS, which means that you're going to put the data together, run a standard OLS regression, and see what comes up. This presents a limitation, which is that it leads to bias and inconsistent estimates if unobserved heterogeneity exists and is correlated with the independent variables. This might happen. Usually when we use panel data, we don't use OLS. Of course, there are examples in which OLS is the best model. You run tests to see which model is more appropriate, and OLS might be there. But usually, if you're analyzing your data, you're probably going to end up using one of those two models that I'm going to present here: fixed effects or random effects. Fixed effects model accounts for unobserved, time invariant individual specific effects by allowing each entity to have its own intercept. I'm not going to get into much detail here because if you access the full example on panel data, I show how you can run this analysis. And of course, you can always check on more information. There's plenty of information available about this model. Let me take my camera out of the way so we can see the full slide. So fixed effects is a model that accounts for unobserved, time invariant, individual specific effects with its own intercept. This is the equation that shows this model. You don't really need to understand this right now. It's more for people that are more interested in the equation. But as you see, it's got the same principle as a linear regression model. You have the dependent variable, a coefficient to an independent variable, and you have this alpha here, which is the fixed effect. It's the key component. It captures all unobserved time invariant vectors for each individual. For example, a company's business culture, an individual's innate ability, and so on. And the other model is the random effects that assumes that the unobserved individual specific effects are random variables that are uncorrelated with the independent variables. So the difference from one to the other is this alpha coefficient here, which captures the fixed effect. So the random effects has this equation here, which differs from the fixed effects because it doesn't have this alpha here. My idea is not to get really specific about this method here at this point, because it's kind of complicated. If you study this in university, you're going to take a full semester to understand those things. And my idea is to give you the tools so you can start running your research right now. So far as at this point, just understand that there are those three models are the most important ones, but we most of the times are going to stick with fixed effects and random effects, and you have to run a test which is called the Hausman test to choose between random effects and fixed effects. And it's a hypothesis test. It's called the null hypothesis, that the unobserved individual specific effects are uncorrelated with independent variables, and then goes for random effects. And if you reject, then you choose fixed effects. But don't worry too much about this right now, because I'm going to show you how to run the Hausman test on our softwares, the softwares that we use in this class. So you can run the Hausman test, choose the best model, the best fixed or random effects model, and then you just apply the model and present it in your paper to analyze your results, right? So this was a very short and brief class on panel data, just for you to know the type of data that you can use if you're working with data that has the panel structure, so multiple entities over longer periods. You are going to work with panel data, and those are the methodologies that you can start working with. And check out the classes on applied panel data methods that I'm going to show on each software, how you can run these tests and how you can interpret the coefficients and the results, which is actually the most important thing. I hope I'm not being boring with this class at this point, but keep on with the studies, keep on watching the classes, because everything's gonna make sense at some point. All right, see you next class.